Look at your life. You are surrounded by miracles of nanolithography and quantum tunneling. You live in the future, right? Wrong. Every time you plug that slab of glass into the wall, you are tethering yourself to the year 1831. That was the year Michael Faraday discovered electromagnetic induction. He figured out that if you spin a magnet inside a coil of wire, electrons move. Simple. Brilliant. But here is the dry, sarcastic truth. Since Faraday, human energy innovation has been a frantic search for more expensive ways to boil water. Coal? A kettle. Natural gas? A cleaner kettle. Nuclear? A multi-billion-dollar kettle. We are trapped in a rotational cult. Thermal power plants dominated by gas turbines account for a staggering 69.34% of global capacity. That means for every 10 bulbs burning in your house, 7 are effectively powered by a 200-year-old mechanism. This is our illusory diversity. We swap fuels just to keep the same magnet spinning. Moving parts are the enemy. They create friction, heat, and enough noise to wake the dead. But what if we could harvest electrons directly from matter? Today, we go beyond the turbine. NASA hates moving parts. When you send a probe into the dark void, you can't send a technician to grease the bearings. You need something silent. This is the radioisotope thermoelectric generator, RTG. It uses a chunk of plutonium-238, a spicy rock, and turns the heat of radioactive decay directly into electricity with zero moving parts. The reliability is terrifying. NASA's RTGs have demonstrated continuous power for more than 30 years without any human intervention. Space agencies hate surprises. Regardless of fuel decay or planetary cold, NASA requires these systems to maintain a stable output of exactly 28 volts DC, the universal standard for space missions. But why use heat at all? Enter beta voltaics, or diamond batteries. We lock radioactive isotopes inside an artificial diamond semiconductor. The diamond catches emitted electrons directly. It's low power, but it lasts centuries, powering a pacemaker for 100 years using recycled nuclear waste. No turbines, no steam, just eternal stillness. I can't run a city on a diamond, you say. True, turbines are heavy lifters, but they have a glass ceiling, the melting point of metal. If you want efficiency, you need heat, but too much heat turns turbine blades into expensive soup. What if we got rid of the blades? Welcome to Magnetohydrodynamics, MHD. Instead of steam, we shoot supersonic ionized gas, a plasma, through a massive magnetic field. Because there are no solid parts to melt, MHD generators can operate at 3000 Kelvin direct from a reactor core. At these extremes, maximum theoretical efficiency reaches 90%, double our best steam plants. But most gases are lazy conductors. To fix this, we seed the hot gases with alkali metals like cesium or potassium to make them conductive. The final boss here is the Hall disk generator, a compact beast that currently holds world records for both efficiency and energy density in MHD generation. It's holding a sun in a magnetic bottle. Attention, restart! Are you still awake? You should be. You are currently radiating up to 200 watts of thermal energy. You are a biological heater. But your arm isn't a volcano, right? Actually, the Seebeck effect only needs a difference. Experiments show that a 14°C gradient, skin versus air, can generate 35.4 millivolts. To make this practical, MIT created Sci-G nanocomposites, an atomic obstacle course. These structures block phonons, heat, while letting electrons zip through, doubling efficiency from 8% to 16%. Millivolts are pathetic, you object. True, but using circuits like the LTC31108, we can drip this voltage into supercapacitors. Once full, it releases a burst of power. We've already powered miniature water pumps and DC motors using nothing but stored ambient heat. It's a silent harvest from your own metabolism. Why are we obsessed with heat? It's just atoms vibrating in a panic. Let's fire the middleman. Enter electrogenic bacteria. While eating organic waste, these microbes exhale electrons directly into electrodes. We are testing microbial fuel cells, MFC, where sewage plants harvest your contributions to power themselves. Or look at osmotic power. Where a river meets the sea, the salt concentration difference is a massive energy potential. Special membranes turn that difference into direct electric current. But the holy grail is aneutronic fusion. Traditional fusion boils water, but aneutronic fusion produces fast-moving charged particles, ions, instead of neutrons. These ions are captured directly into an electrical circuit. No steam, no spinning magnets, no radioactive waste. From a star's heart to your toaster. The future is silent and static. Even information has a physical floor called the Landauer limit, which states the minimum energy to erase one bit of data is 2.9 times 10 to the minus 21 joules at room temperature. Current computers are 1 billion times less efficient. By moving to direct generation, we align with the fundamental limits of the universe. This is the end of the machine age. The real civilizational leap happens when we leave Earth. Turbines are weight-heavy nightmares in space because they rely on the Carnot cycle, which fails in a vacuum. Direct generation increases our ability to mine cosmic energy by orders of magnitude. We stop being a species that boils water and start capturing the breath of stars. If the idea of a skin-powered watch fascinates you, type Seebeck in the comments. I want to see who's paying attention. Like and subscribe, or Faraday's ghost will haunt your kettle.